In materials science, understanding what happens at the surface of a material is often the key to explaining its behavior. Surface chemistry governs many critical phenomena such as corrosion resistance, adhesion, catalytic activity, and electronic performance. To investigate these surface-related processes, researchers rely on X-ray Photoelectron Spectroscopy, commonly known as XPS, one of the most powerful and precise techniques for surface characterization. XPS provides a detailed fingerprint of the outermost atomic layers of a material, revealing both the elemental composition and the chemical states of surface atoms within just a few nanometers of depth. When a material is irradiated with X-rays, photoelectrons are emitted with specific binding energies that are characteristic of each element and its oxidation state. By analyzing these signals, XPS allows us to identify not only which elements are present, but also how they are bonded, distinguishing, for instance, between metallic, oxidized, or hydroxylated species of the same element. This level of precision makes XPS indispensable in areas such as thin film coatings, nanocomposites, corrosion studies, catalysis, and semiconductor research. However, the true value of XPS data lies not merely in acquiring spectra, but in how accurately those spectra are processed, interpreted, and reported. Raw XPS spectra often contain overlapping peaks, charging effects, background noise, and other distortions that can complicate interpretation. A small error in background subtraction, curve fitting, or chemical state assignment can completely alter the final conclusion and, as a result, compromise the scientific validity of a study. Therefore, precise and reproducible data processing is not just a technical step, but a scientific necessity. Today, most high-impact journals require clear documentation of XPS data analysis procedures, including the type of background used, fitting models, and parameters for peak deconvolution. Accurate and transparent analysis is what gives credibility to published results. For this purpose, researchers around the world use CasaXPS, one of the most reliable and widely adopted software tools for XPS data analysis. CasaXPS enables scientists to perform background correction, smooth spectra, and separate overlapping components through sophisticated peak fitting and deconvolution algorithms. The software also allows the construction of depth profiles, which reveal how elemental concentrations evolve with sputtering depth. This information is particularly valuable for studying thin films, multilayer coatings, diffusion zones, and interfacial reactions. By carefully fitting and validating the data, CasaXPS helps extract essential parameters such as binding energy shifts, atomic ratios, and oxidation states, the foundation for accurate interpretation and publication quality results. At analyzestest.com, we specialize in PROFs.